tragic. F of x equals to x to the power 4 minus 16x cubed plus 70x squared minus 48x minus 135 has met his demise. It's crazy. The killer left no trace behind. It's like he disappeared out of thin air.
It's astonishing. We have to stay sharp and examine every detail.
Have you found anything?
Absolutely nothing. It's crazy. It's like the killer was a ghost. He left no remainder.
You have to think strategically. Oh, why not let's look for his x's?
His exes?
Yeah, I'm sure a long polynomial like him would have a lot of them. Just trust me on this one.
All right, let's begin. We're looking to find the person who killed FX. A lot of evidence from our investigation suggests that you're one of the possible suspects.
I swear it wasn't me. I have no reason to harm FX. You cannot prove anything.
I don't know what you're talking about. I haven't seen FX in years.
Why would I want to harm FX? He is a very good comrade of mine. We are on very good terms.
We have evidence that someone killed FX and left no remainder. This suggests a deeper connection. We need to get to the truth.
Exactly. We suspect the person who did it had a significant relationship with FX.
Well, I mean, I did have a close relationship with them at some point, but I haven't seen them recently at all.
This is ridiculous. You're wasting your time. You're wasting my time. I have nothing to do with FX.
I admit we've had our differences, but I would never resort to doing something like that. I've moved on.
I have no idea why you suspect me. I have nothing to gain from FX's death.
We're not leaving any stone unturned. We will continue our investigation until we find out the truth. But how do we get to the root of the issue?
The roots! Stanley, I've got it! We can prove the killer's identity using the Factor Theorem.
The Factor Theorem?
Yeah, the Factor Theorem. Let me show you. The Factor Theorem says that if x minus k is a factor of fx, then f of k must equal 0.
What? And why is that?
A factor is an expression that divides a polynomial evenly. That is, any polynomial can be expressed in terms of the product of its factors. This is called factored form, as you can see here. In this example, x minus a is a factor where a is just a root. So if you plug in any of the roots of this equation into f of x, for example, if you plug in a, the result will always give you 0. That's how the factor theorem works. We know that the killer left 0 remainder at the scene, which means whoever did it must be a factor of fx.
Yeah, I'm following you so far. We can use this property to our advantage.
We need to evaluate fx for each suspect, substituting their root into the polynomial. If we find a suspect whose root makes fx equal 0, we'll have our killer.
That's brilliant, Zoe! By using the Factor Theorem, we can find out who the killer is mathematically. Start with x plus 1, and that means the root would have to be -1. So that's what we need to substitute within the equation. So we have f -1, we have -1 to the power 4 minus 16 times -1 to the power 3 plus 70 times -1 to the power 2 minus 48 times -1 minus 135. So that would be 1 plus 16 plus 70 plus 48 minus 135. Those added together, you get 87 plus 48 minus 135 plus 135 minus 135, and we get 0. Zoe, x plus 1 is the killer.
You're right, and that makes sense too. That's why there was nothing left at the crime scene. This is great. Let's bring this evidence back to the board.
Wait, hold on, Zoe. Before you proceed, something doesn't sit right with me. If x plus 1 is a factor of f of x, that means f of x is divisible by x plus 1, right?
Yeah? What's the issue with that?
And if f of x is divisible by x plus 1, then surely f of x is x plus 1 multiplied by something else, right?
Yeah?
So then there must be something we're missing. X plus 1 is not the only factor of f of x. He wasn't working alone.
You're right. Let's reevaluate our findings. We can find the quotient of fx divided by x plus 1 by using polynomial long division or synthetic division. What happened? happened to our rooms?
Don't worry about it. Let's finish this division first. So as you can see, we can set it up like how we would do with long division with integers, like we usually did. So our original f of x would be the dividend and x plus 1 would be the divisor. So we would do that, as we said, the same thing as long division. So we need to find out a number that we can multiply to x plus 1 in order to eliminate the first term, which is x to the power 4. And we can do that by multiplying this to x to the power 3. That's right. So x to the power 3 multiplied with this would be x to the power 4 plus x to the power 3. And then we subtract that from the original function, get negative 17x cubed plus 70x squared. And we keep going. What can we multiply x plus 1 by to get negative 17x cubed? That would be negative 17x squared. So that would give us negative 17x cubed minus 17x squared. Then we keep going. 70 minus. Which our last term can be negative 135. And as expected, we get our final remainder of 0 because we know x plus 1 is a factor.
I'm following, but I think there's another way to do it. Have you heard of synthetic division?
Synthetic division. Isn't that the thing I mentioned earlier?
It is. Let me show you how to do it. In order to set up synthetic long division, we start by writing the coefficients of each term in your original polynomial. In this case, it's 1, negative 16, 70, negative 48, and negative 135. On the left of this, you write the root. So in our case, where we're dividing by x plus 1, the root is negative 1. It's a note that synthetic division only works if you're using a linear divisor. Using something like a quadratic to divide a polynomial of a higher degree won't actually work. To continue with our synthetic division, we start by bringing down the first term. That is 1. Once a term is on the bottom, you can multiply it by the root. In this case, 1 times negative 1 is negative 1. Then you add up the terms in each column. Negative 16 minus 1 is negative 17. Multiply by negative 1 again, and you get 17. 70 plus 17 is 87. Multiply by negative 1, you get negative 87. Adding these two terms together, you get negative 135. Multiply by negative 1 is 135. And negative 135 plus 135 is 0. Making our final polynomial x cubed minus 17x squared plus 87x minus 135.
Oh, that was exactly what I got, and that was so much quicker.
I know, synthetic division really is the best.
In fact, we can find the other factors by keep factoring the quotient until it's in its factor form.
That's facts. Let's start by substituting the other suspects into the polynomial. The next on the list is x minus 9. Stanley, look! When we substitute x minus 9 into the polynomial, fx equals 0.
You're right, Zoe. It's not just x plus 1. X minus 9 is also a valid factor that produces 0. This means that there just isn't one killer, but possibly many people involved. This changes everything. Let's try the last two suspects.
Look, Stanley, x minus 5 is a factor of fx.
So is x minus 3.
Does this mean they all did it?
This can't be a coincidence. According to the Factor Theorem, all 4 suspects are factors of fx.
It means all 4 of them were involved in the crime. They each played a part in killing fx.
Can't believe it. We were so focused on a single killer that we completely overlooked the possibility of a collective effort. Sometimes the truth hides itself in plain sight, disguised by our own narrow focus.